Alright, so this is the last chapter in chapter 2 where we are going to graph linear inequalities with two variables. This is something we've done before. Um, when we are graphing these types of equations, when we have y in slope-intercept form, we make our lines or dashes depending on what kind of inequality we have. If it's a greater than or less than sign, it's a dash line. If it's a greater than or equal to or less than or equal to, we use a solid line. Um, you can then use solutions for ordered pairs to make sure that these inequalities are true. Here, what we're trying to do is I want to be able to see if the equation 4x minus 3y is greater than negative 24, I want to see if it holds true with these ordered pairs, negative 4 comma 2, negative 10 comma negative 5, and negative 3 comma 4. So how I determine that is I substitute it in to this equation. So if my x here is negative 4, I'm going to use negative 4 for x. Minus 3 times 2 is greater than negative 24. Negative 4 times 4 is negative 16. Minus 6 is greater than negative 24. And negative 16 minus 6 is negative 22, which is greater than negative 24. Is this a true statement? Yes, it is. So I can say that this is yes, this is a solution of that equation. Same thing goes for example B. So I'm going to go 4 times negative 10 minus 3 times negative 5 is greater than negative 24. 4 times negative 10 is negative 40. This becomes plus 15 because of the two negatives, greater than negative 24. Negative 40 plus 15 is a negative 25, and then it's greater than negative 24. This is not a true statement, so I would say that this is not a solution. And then the last one, look at 4 times negative 3 minus 3 times 4 is greater than negative 24. 4 times negative 3 is negative 12, minus 12 is greater than negative 24. Negative 12 minus 12 is negative 24, is greater than negative 24. This happens to be not a true statement because it would have to be greater than or equal to in my inequality to prove that this would hold true, but so that's what we're kind of looking for. When it comes to graphing inequalities, first thing we have to do is, if we do have a y, to get y by itself. Once we do that, we then look at the different inequalities. We use a solid line if it's the less than or greater than or equal to, and we use the dashed lines for the less than or greater than. Next thing we have to do is do a test point that's not on the line so we can see where we shade. More often than none, we use 0, 0 for our test point as long as that's not part of the boundary line. And if we use 0, 0, for instance, and when we plug those values into our equation and it shows up as a true statement, then we shade that side that the test point is on. If it's a false statement, then we shade away from the test point side. So let me show you what I'm talking about. So for my first example, I want to graph this inequality, which is y is less than or equal to 5. So if I just pretend like this was y equals 5, that's actually going to be a horizontal line going at the point where y equals 5. So 1, 2, 3, 4, 5. And it's a horizontal line that is a solid line because of the greater, less than or equal to. And from here, I need to make a test point. So I'm going to use 0, 0, 0 as my test point. So I'm going to substitute in y for 0 and see if this statement is true. this statement is true, and since it is, I get to shade along the side of the boundary line where my test point was located. If it was a false statement, then I'd have to shade on the other side. Okay? B is x is less than negative 3. So this one's going to be a vertical line where pointing at where x is at negative 3. This happens to be a dashed line because of it's just greater than. There's no equal to attached to it. So I'm going to use my test point again at 0, 0. So now I have 0 is greater than negative 3. True statement? Yes, it is. So that means I get to shade along the side of my test point. Next one is y is less than or equal to negative 3/4 x plus 5. So now we do the same thing as like we were making a line. So I need to find my y-intercept. My y-intercept is positive 5. So 1, 2, 3, 4, 5. And then my slope is a negative 3/4. So I can either go down 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. Or I could go up 3, 1, 2, 3, and to the left 4, 1, 2, 3, 4. Either way, you're still going to make the same line. And it's a solid line because of the less than or equal to. From here, I'm going to use my test point, 0, 0, because I can. So I'm going to say 0 is less than or equal to negative 3/4 times 0 plus 5. So now I can say 0 is less than or equal to 5. True statement? Yes, it is. So that means that I get to shade this portion of my boundary line. For D, the first thing I got to do is get y by itself. So I'm going to subtract negative 9x to both sides. So that leaves me with 3y is less than negative 9x. Now I get to divide both sides by 3, which leaves me with y is less than negative 3x. From here, I don't have a b, so my b is 0, so that means that my y-intercept is at the origin. And then my slope is at negative 3, 1. So I could either go down 3, 1, 2, 3, to the right 1, or I could go up 3, 1, 2, 3, to the left 1. Either way, still going to get the same line. It's going to be a dashed line. But the only thing that's going to be different here is that I cannot use the origin to help me do my shading because my origin is part of my boundary line. So I'm going to pick a different point. I'm going to say let's pick 1, 1. So that means if y is 1, my x is also going to be 1 here because it's my test point. So I'm going to say 1 is less than negative 3. Is this a true statement? No, it is not. So since it's a false statement and my test point occurred on the right-hand side of my boundary line, that means I get to shade the left side of my boundary line. A new little wrinkle here is now we're going to use absolute value. Absolute value was graphs that we worked in the section prior. And again, originally our point starts at 0, 0, but if you look here, we're going to have some shifting involved. And we're going to shift 4 units to the left, 1, 2, 3, 4, and then 4 units up, 1, 2, 3, 4. So our new vertex in this case is going to be located at negative 4, 4. So again, when I'm making my table, x and y, negative 4 is going to be in my middle. So then I'm gonna pick a couple points that are lower than this. So let's say negative 5 and negative 6. And I'm going to make a couple points that are larger than that. So let's go negative 3 and negative 2. So then all I'm going to do is substitute in these x values in for x in this equation and then solve for y. And when I do that, if my x is negative 6, my y will be positive 3. If my x is negative 5, my y is 3.5. If my x is negative 4, my y is 4. If my x is negative 3, my y is 3.5. And if my x is negative 2, my y is 3. So I'm going to plot these points. So let's go negative 6, 1, 2, 3. If I got negative 5, that's going to be 3.5. So it looks right here and right here. Okay. So now I have to notice to see if I'm going to use a dash line or a solid line. I'm going to use a dash line because of my less than symbol. So there's my absolute value graph. Now the last thing we got to do is we're going to use a test point. So I'm going to use 0, 0 as my test point. So I'm going to say 0 is less than negative 1/2 times 0 plus 4 of the absolute value, all of which is plus 4. And if I do the math, 0 plus 4 is 4. The absolute value of 4 is 4. 4 times a negative 1/2 is a negative 2. Negative 2 plus 4, so it'd be 0 is less than 2. Is this a true statement? Yes, it is. And since my test point is right in here, I get to shade everything that would be underneath this absolute value mark. Okay? Looking at B, first I got to get y by itself, so I'm going to subtract 3 to both sides. So now it's y is less than 2 times the absolute value of x minus 1, all of which is minus 3. So from here, originally it's usually at the origin, our vertex, but we have some shifting involved, so that means it's going to be to the right 1, down 3. So my new vertex is going to be at this point right here. So when I make my table, my center one will be a positive 1, so I'm going to use a couple values that are smaller than that, so I'm going to use 0 and negative 1, and then I'm going to use a couple values that are larger than 1, so 2 and 3. And I'm going to substitute them in. So my negative, if I put negative 1 in for x, my y is 1. If I put in 0 in for x, my y is negative 1. If I put in 1 in for x, my y is negative 3. If I put in 2 in for x, my y is negative 1. And if I put 3 in for x, my y is 1. So if I plot these points, so if I go negative 1, 1, 0, negative 1, I've already got the plotted of 1 comma negative 3, be 2 comma negative 1, 3 comma 1. So, and this is a dash line. Okay? Now I can use the test point of 0 comma 0 because it's not on the boundary line. So I say 0 is less than 2 times the absolute value of 0 minus 1, all minus 3. Let's see here. So I got 0 is less than, what's here? 0 minus 1 is negative 1. The absolute value of negative 1 is 1. 1 times 2 is 2. 2 minus 3 gives me a negative 1. Is this a true statement? No, it is not. So that means I have to shade the portions that is not part of selected from my boundary point. So that's where the shading occurs. And if you enjoy a little story problem, here's one. So the example I'm going to show you here is you have 2 part-time summer jobs. One that pays $9 an hour and another that pays $12 an hour. You would like to earn at least $240 a week. Write an inequality describing the amount of time you can schedule at both jobs. Graph the inequality, and then let's identify 3 possible solutions of the inequality. What are the parameters of the inequality and why? So if I look at this graph, let's just say that this starting here, this is 0 comma 0. Okay? And for me to write an inequality for this, I'm going to use x and y. I'm going to say x is part of the job that pays $9 an hour plus the job that pays $12 an hour, we represent it as y. And I want to make at least $240. I can make more than $240, but I can't. I want to make at least $240, so I must put a greater than or equal to attached to my um, inequality. So again, if I were to just look at this graphically, what if I just used, I'm going to make 2 points, one of which will be on my y axis, the other one's going to be on my x axis. So if I chose just to make all my money from job Y and none of it from job X, if I wanted to make just 200 my $240 off from Y, I would have to have worked 22 hours a week. So if I just say these are by twos, so I'm going to say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So this is 20. This is 20 right here. So if I work 20 hours a week, I could earn the $240 just from job Y. If I just did just from job X, it would take me 26.66 hours. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I would say it's roughly right about there. And since it's a greater than or equal to, it is a solid line. And the shading would occur here on the right hand side because I can make more than $240. And so any point, let's say I made a point right here, if I made a point right there, if I made a point right there, those are all three possible solutions for this particular inequality. Reasons for that is the parameters state that I have to make at least $240 a week, and I could use both jobs to help me achieve my goal. So there you go. And this is graphing linear inequalities with two variables. Hope this helps. Until next time.